Hi there. In this tutorial I'm going to talk about some of the elements of how I created this short sequence. So as you can see, we've got this strange object in the middle, and it seems to be emitting some particles that orbit around it a little bit, strange sort of iris effect around it, and there's this watery effect in the middle, and then the camera zooms through and back out again. So to begin with, I'm just going to create a simple icosphere, but with quite a few subdivisions just to make it reasonably smooth. Focus in on that and go to orthographic view, and I'm going to scale it on the y-axis to be quite flat. Doesn't really matter, it's just that's what I did for this particular one. I'm going to turn the grid view off and we'll set it to smooth shading. I'm going to add a new material, but I'm just going to call it black. Now in the node editor, which I'm just calling up, I could just set this to black and that would work. I can just delete that material and that will work for what I want to do. Or if you want to do it properly, add a shader which is the holdout shader. So this will just make sure that whatever happens, there's no reflection, no light of any description bounces off this object. Any of those things will work. And in the settings I'm going to set it fairly dark so we can remember what it is. This is basically our particle emitter. I'm going to add a new material and I'm going to call that particle. And for the moment we'll just make this an emissive material and give it a bit of an orangey yellow colour. I'm also going to give it a pass index of 1 and we'll come back to that later. So I now need to create a particle, so I'm going to go into a different layer and add another icosphere. This time I'm going to have a lot of these, so I really don't want too many subdivisions. Probably one subdivision is fine. You could probably even get away with a cube. And I'm going to click here and select my particle. Now the reason that I created the particle material on the main emitter object is it just makes it easier to quickly select that material rather than having to go and find my particle and go from there. And we'll call the object particle, back to our main layer, and we'll call this main emitter, and we'll come over to particle systems and add a new particle system. When I did this, I created this over 500 frames, so let's change this to 500 down here. I actually ended up with creating 75,000 particles, but for the moment we'll leave it at the default of 1,000, and we'll set the end time to 500, so it doesn't stop emitting particles till then. I had a lifetime of 150, and I added a small amount of random, something like that. All of this I left at default. If you add a subdivision surface, it's worth clicking Use Modifier Stack. Come on down here, physics should be on the default of Newtonian. I clicked multiply mass with size. If you have any mass calculations, that will take account of any variation in size of your particles, and they will be varying in size. I used a Brownian value of 0.02. All of these settings will vary in how much they affect it depending on the scale and things like that of your model. My Patreon patrons, I will upload the original file that I created so you can have a look at it yourself. Under damping I put 0.075. If your animation is very fast or emitting your particles at a fairly high speed, you may want to use subframes. That will add to the calculation load, so I left that at default. Coming on down, we want to render our initial material, which we've called black, and we want our emitter to be rendered. The reason for that is because I'm going to have a star background and I want it to occlude some of the stars. We want to emit objects, so if we click in here we can select our particle. We want to affect scale, and we'll set that at about 0.9 for the random size, and the overall size 0.01 is what I selected. Again, we may need to tweak this in a moment. So if we press play now, you can see we're getting little particles emitted and they're just falling. So if we come on further down, under field weights, we'll turn gravity completely off, and now they just emit out. Go back to the beginning of the animation, you can just about see them there coming out and not really getting very far, and that's because of this damping value that takes the emission energy out of them. So this is the emission energy here, so this will control how fast the particles initially come streaming out. I had mine at about 0.5. Let's see what that looks like. Occasionally it may not seem to take any account of what you've done, so just change the random seed or something like that and it will recalculate the cache. And there we can see them coming out, but at the moment you can see they're coming out of all parts of this object. I wanted them to just really come out of the edge. So what I need to do, go into wireframe mode, select everything, press C to give me a circular selector, I just made it a little bit smaller than my flattened sphere, something like that initially, and then middle mouse button just to deselect everything except that rim. If you use a UV sphere, it's actually easier to do that, but I prefer the icosphere for a lot of things. Then come over to here for vertex settings and click plus on the vertex groups and assign. Press A to unselect and then select here. You can see we've just that ring of vertices selected now. So go back to our particle system, come down to vertex groups, click in here and select our group. So if we now press play, you can see they're just coming out of that rim now. So we're just getting a ring of them created. It's slightly more than just the very edge, so it creates a slightly thickened ring rather than a completely flat one. So next, let's create that sort of water effect in the middle. So I'm going to add a circle. I'm going to rotate it on the X 90. I'm going to press G and Y just to pull it forward a little, shrink it down slightly, go into edit mode, press the space bar, type fill and select grid fill. And that gives us a nice flat plane. One thing to be aware of if you're just using a flat plane like this is that there is a direction for the normals and it's not always obvious. So we go into edit mode, we can come and turn the normals on here and you can see they're all pointing that way. That's basically the real surface. This isn't a proper surface as far as Blender is concerned. You can flip them or you can just rotate on the X 180 and now you can see it's slightly brighter. If we look at our normals, they're pointing outward now. So we'll turn that off now and we'll go in a little bit. At this point what I did was, if I look at my flattened sphere, I actually played around with the shape a little bit more. That's probably the center there. Control plus just to expand that just a little bit. Press O to turn on proportional editing and then we'll try sharp to start with and we'll say scale on the Y. What I'm trying to do, in fact we use smooth scale Y, is just sort of have a dimple in the middle there. So you can see it sort of has gone through itself there, so just out from there. But we maybe need to make it a little bigger than that, the influence. So now it's really a slightly strange shape. But the reason for doing that is that when I move this inward, you can see the edges will disappear into that object, which is what I wanted. So I'm going to move that plane just to the next layer now so we can work on it in isolation. And I'm going to press W and say subdivide. And I'm also going to press Ctrl 2 to add a subdivision surface to it, and there it is. So that's a nice smooth plane right now. And we're going to add another modifier called a displace modifier. And you can see that looks pretty strange at the moment. But if we look straight on, with it all selected, I'm just going to press U and project from view bound. So we've UV unwrapped that. I'm going to push the displace modifier above the subdivision surface, and I'm going to set it to smooth shading. I'm going to worry about what the shape is at the moment. I'm going to set the strength to 0.4 initially, and I'm going to say new for the texture, and I'm going to set the texture coordinates to UV and the UV map. Next, I'm going to go into edit mode. I'm just going to select everything except the very outer ring of vertices, as you can see here, then add a vertex group and assign that, and then just reselect it just to check. And that's because I don't want the displace modifier to affect the very edge of this object, because otherwise that will come sort of flapping around visibly. Click in here and select group, and you can now see that edge stays where it was. If I play around with the mid-level parameter, the displace modifier is not affecting that very edge, so wherever I put that it's going to stay there. So we can give the texture a name, we'll give it a name like noise, and then if we click this little button we'll go to the texture options, click in here and select clouds. Now we're getting something more recognizable. I stuck with Blender Original. Depth I actually set at 0. Nabla didn't really make any difference for this application. The main thing I did in here is I animated the size. So I'm just expanding this out a little bit. Once you've got a noise size which is acceptable, so a number of ripples that are the sort of frequency that you want, so 0.1 seems to be fairly good for this one. I had a somewhat smaller number. Press I, then go to the end of the animation and change this a tiny amount. If you go too much, it will just be animating too fast. So let's try 0.15 and then press I. Now initially this is going to be slow and then it's going to speed up the movement, but you can at least see what it's doing there. And around the middle it'll be at its fastest, and then it will slow down again towards the end. And that's because of the Bezier curve that's initially used for the animation. If we go to the graph editor, click key, interpolation mode, and then say linear, and then back to our 3D view, we should be able to see that that all now is just a continuous animation. And if we want it to go a bit faster, we can just go to the end animation, change that number to perhaps 0.25, press I again with the mouse hovering over it so it turns yellow, and now when we press play you can see it's a bit quicker. So let's just set the material for this object now. At this point I'm going to put a lamp in the scene just so that we can see what we're doing. I didn't use a lamp I think in the end, but we'll just put a point light here. So that's just a undefined material at the moment, so we'll say new material, and all I did was just take the diffuse away, add a shader which is a glossy, connect that in, set that to Ashman Shirley. I used a slightly blue colour, very slightly, and a very small roughness of 0.001, so it's a very shiny subject. Now if we scroll through, there's not anything else at the moment to reflect in the scene, so we're not seeing an awful lot. I'll put a couple more in, and if I put a sky texture on, now you can see what we've got. You can see how it's changing strangely there. And we can adjust the strength of it here to make it more or less as we want to. So that's all we needed to do for that. We go back to solid view, come over here, and then call this up. We can see how that's lining up with our main object. And if you find the edge is lifting up at all, you can either move it a little deeper into the main object, or you can increase that vertex group that was defining what is affected by the displacement. So that's that part, and now we need to do a little bit with our particles. So if you recall, we've got our material for our particles here, and this is probably the most complex of the shaders for this tutorial, although it's not that complicated. So here's our emission shader, and I'm going to add a converter which is a color ramp, and the output of that's going into the color of the emission shader. I'm also going to add an input node, which is an object info input node, and take the random output of that and connect it into the color ramp. And basically every time you create an object or a copy of an object, this node will create a new random number between 0 and 1 out of that output. So essentially each particle we create will have a new random number allocated to it. So let's create a few more points in this color ramp. Let's set this one to white, this one to a bright sort of yellowy white, this one will have a bright orange, this one perhaps a deeper orange, and then this one perhaps will have almost a red colour. And if we lift that up a little bit, it'll increase the number of particles that are of that colour. And you can obviously put anything you want in there. So this will randomly select a colour for the particle between those ranges. But we want to do more than that, so let's add a few more controls to the brightness of the particle, the strength of it. So I'm going to add an input which is a particle info node, and then I'm going to add a converter which is a math node, set to divide, and I'm going to take the age of the particle, which is represented from this output, and put that on one side, and the lifetime, and put that on the other. Now from the particle information you may remember our particle's lifetime is 150, so this will basically give us a value that tells us how far along that lifetime the particle is, whether it's just been born or whether it's just died. For scaling reasons, to get the sort of effect that I was looking for, I added a couple more math nodes. One was a subtract node and one was a multiply node. Whether you need these, it just depends on the effect you're trying to achieve, so you can give them a go. So I put the output of that divide node into one side of my subtract node, and on the top I just set that to 1, so I subtracted 1 from it. The output of that goes into my multiply node. I set that at about 12, and then the output of that is into my strength on my emission. So let's just create a few particles. We zoom in a bit. You may frequently find that particle systems will get messed up, so you just need to play around with a value until that red bar goes light coloured, and then when you press play it'll create them as normal. And now if we look at rendered view, you can see we've got particles of all sorts of different colours, and what will also be happening is that they are getting brighter and darker. We wanted these particles to be quite bright to start with and then fade over time rather than just disappearing all of a sudden. So that's really what this is all about. And you can see we've got various different colours in there as before. So that's the majority of the setup. We do need to create the star background. I've done this many times before, so I'll show you again how I did that. Come over to here, which is our world. At the moment we've got nothing there. You'll probably have the background node in there when you go there. There's nothing there because I removed it a moment ago. and we'll set that to black. So there's the world output, and that's black. And there it is. There's our object, and it's all black all around it. So I'm going to add my usual noise texture, set to 300, detail of 16. You can go higher, and that goes into the color input of my background node. If I come out of orthographic view, you can now see we've got this sort of colored dots appearing here. So I now take a color ramp. You can either take from the color or from the factor to go into that color ramp. Bring the two pointers close together, add another converter which is a math node, set that to multiply, take the output of the color ramp into one side of that, and I set that to 5, and then I connected that into the background strength, and now all of a sudden we've got a star field, and we can now play around with these points to adjust the density of our star field. So if we take that up here, you can see we've got more variation in color and brightness of stars, but they're possibly a little less well defined as well. If we bring the black pointer up, you can see the stars disappear basically. So taking it to the left increases the density, taking it to the right decreases it, but also creates sharper points. And then I can bring this one back down to here, and that'll increase the number of stars a little bit as well. But doing it this way means that I actually get some color variation in the stars. It's not obvious because they're so small, but they're not all just white stars. And you can use this to create a variation in how bright those stars are. So we can set it to 10 and they're much brighter, for example. You can just see our object in there. So one of the strange things I have noticed is occasionally you'll get stars rendered where there shouldn't be any. So for example, if I open another window and we look through the camera view for both of these, this is what the camera is seeing right now. So we know if I started emitting particles, there is our object just in there. But we can actually see stars in there. If I turn the particle visibility off, there are still stars there. And I guess this is just a bug, but there is a workaround. So if we go to our node editor again and we add a color mix node, and we drop that in there between the noise texture output and the background. I actually want it on the bottom node, and on the top node I just want that set to black. I now add new input, which is a light path input. It's quite a large one. I'll zoom in on that a bit. And we want to take the output which says is camera ray. So basically, is it a ray that's going straight to the camera or not? Take that output and put it into the factor. Now you can see all those anomalous stars that were in the middle here, which shouldn't be visible, disappeared. Take it away, they come back. So that's just a nice quick way to clean that up. So now our black object really does occlude the stars as you'd expect it to. And you can see there's our particles and there's nothing in the middle. One last little thing about the particles. I wanted my particles to be emitting right the way from the beginning of the animation. Now obviously you can just start rendering a bit further in, but what you can also do is start your particles before the animation starts. So I actually set the start number to -100. We'll need to just tweak this up here a little bit. Go to the beginning, and already you can see we've got a ring of particles, and they carry on emitting as we go. So that's a quick way just to make sure that you've got the particles there already, rather than having to wait before you start rendering. So starting rendering at say frame 50 or something, I've already got them visible there. So now for the final part, which is the compositing at the end, which adds the final effect. So before we do that, let's just see what we're seeing in the camera. So I'm just going to move my camera slightly and zoom it in a little bit just so we get a good view. I've still got these lights on in here, but it doesn't matter too much. We'll let it emit a few more particles and then we'll render. What we're seeing here is actually reflections of these particles. In fact, what I'm going to do now is I'm going to turn the number of my particles up significantly. So rather than 75,000, which is what I used, let's just do 25,000. And that's a lot more, as you can see. And that will collectively emit a lot more light as well, which is what we're getting now reflected in here, which is what I wanted. We're obviously seeing mirrored reflections of these illuminated particles. So now if we go to here and say use nodes, we can add our compositing nodes. So we need to be able to differentiate between one material and another, especially if you had other things in this scene that you didn't necessarily want to apply all of these effects to. So we're going to re-render, but this time under passes I'm going to turn on material index. And you notice we got an extra little option up here when I did that. One of the good things about scenes like this is you don't have to render an awful lot of samples to get a reasonable result. And also, if there are any fireflies in it, it just looks like part of the scene anyway. If you recall, the particle material had a pass index of 1. So we've just set this for our passes to have a material index. So let's add a converter, which is an ID mask, and connect it to the index MA, which is the material index. If we just look at what that's outputting, everything's white except for the particles. If I turn that up 1, now everything is black or not selected except for the particles. And I usually switch on anti-aliasing as well, which just smooths out edges, although it's not that important for tiny little dots like this. So I'll put my image back into the output, and I'm going to add a color mix node. On the top I'm going to make it just completely black. Onto the bottom I'm going to put our image, so let's take that out. It doesn't look any different at the moment, but I'm going to take my ID mask and put that at the top. And what you should have seen is all the stars disappeared. This doesn't work 100% with backgrounds, but it works sufficiently well. So essentially I've filtered out everything except for the particles. So now I'm going to add a filter, which is a glare node. Just drop that in there. And I used fog glow. I had a mix of 1, a threshold of 0.4 and a size of 9. So that's given us some quite extreme glow there. Then added another node from the filter section, which is the sunbeams node. And just to show you precisely what this is doing, I'm going to connect that image into my sunbeams node, and I'm going to replace what I'm outputting at the moment with the sunbeams node. And initially it doesn't show anything, but that's because the ray length is at 0. So I used about 0.064, and suddenly we've got something back. And you can see all those particles have created these streaks. So I want to add that to the glow node. It also has an alpha background, which is of note. I'm going to add another color mix node. Drop that there, set this to add, and have my glare node output on the other side. So now you can see we've got our glare on there and we've got our streaks from our sunbeams node. It's worth noting that sunbeams node isn't particularly clever. If the object that you want to do this to is moving around the scene, you will need to animate these values, which identify proportionally where in the image the sunbeams should derive from. So 0.5 means that obviously the middle of the image. That's X and Y. So if that was 0, that would be over on the left, and if it's 1, it's over on the right, and so on. It's a relatively simple little node, but it can create some quite dramatic effects. And obviously you can use it for sunbeams too, and it's a lot quicker to do than actual volumetrics. So that's the main effect there, and we just want to blend that in with our original image. So let's take a copy of our add node, drop that there, and drop our original image in as well. So now you can see we've got our stars in the background, and we've got this. Now there's one little bug that I've been unable to resolve completely, and that is some of your stars will also get the sunbeam effect. I've checked and I can't find any node-based reason why that's happening. It just seems like for the sunbeam node, enough of the data gets through this filter that it picks it up and shows the streaks. It's not a major effect, and I think it's fine really. So I hope you found that interesting. If you did, let me know. My Patreon patrons will be able to download a copy of the original file, and I'll see you in the next tutorial. Thanks a lot. So I hope you found that interesting. If you did, let me know. If you enjoy these tutorials, don't forget to click like and subscribe. I also have a Facebook page and a Twitter account, and I now have a Patreon page as well, and I'll provide links to all of those in the description below. So I'll see you in the next tutorial. Thanks a lot.